Hi, this is Tim Weber from South Texas College and coming to you with another lecture video. This one is going to be on middle childhood, and we'll focus a little bit on physical development, but spend most of the time on the development of the mind and various cognitive processes. So to begin, the middle childhood comprised of age 6 through 11 is one of the healthiest portions of the lifespan in general. Some of the illnesses that a child might have very early on starting out have already passed, but yet many of the health problems that set in later in life have not yet appeared. So that said, there are a couple of health conditions that are quite prevalent in this age group, and so we'll have a brief look at a couple of these, and one being asthma. So asthma is the most common chronic disease in this age group. 1 out of 10 kids in the US have had an asthma attack, and while this is rarely lethal, that said, it can be a very frightening as well as limiting condition for kids. Rates of asthma have been increasing in our population and amongst children in particular. There are many attempts to explain why. One of the most likely candidates as a good explanation is the hygiene hypothesis. So this theory goes this way. The idea is our immune systems, that's our systems that are engaged in fighting bacteria and viruses and wiping out disease cells, basically fighting off disease and illness. Our immune system is designed to be active and engaged. And so for our ancestors, there were all sorts of microbes for it to take care of, and it had no lack of things to do. However, in today's environment, where we use all sorts of sanitizers and we no longer let kids go out and play in the dirt as much as they used to, the immune system is idle to a great extent, not engaged, and so essentially it begins to look for things to attack and begins to attack things that are not dangerous, things like pollen and pet dander and all sorts of other substances that we're exposed to on a regular basis. Whereas if it were more busier fighting microbes, then it would not be attacking these things. So that produces then allergic reactions that lead to finally asthma attacks. So that's the idea. I think there's probably some validity because kids are kept indoors in a cleaner environment today than years ago. Maybe it's a good idea to encourage kids to go out, run around, get a little bit dirty, get their hands in the dirt. This may actually be good. So in terms of prevention, one of the things that can help prevent asthma is if the child received breastfeeding early on. If a child already has developed asthma, then we're down to treating it. And the strategy would be to reduce the allergens that are present in their home, treat symptoms if they've already developed. It turns out that if we don't treat the symptoms, it tends to progress to worse more quickly. And also to improve ventilation and air quality in the child's environment. A second health problem that has become common in middle childhood is obesity. And if you look at this chart is tracking up until 2004, and you'll notice the tremendous increase in the prevalence of overweight children beginning in the 1970s. That trend since 2004 has leveled a bit, but it's still extremely high. Still, we have 20% of kids being overweight. This was not the case a generation or two ago. So how do we account for this increase in obesity and overweight? Well, some people will point to genes, but we can't really blame our genes. Genes don't change that rapidly in a population that we can say, well, there's kids today are genetically different. What we can point to are changes in lifestyle and changes also in activity patterns, exercise, as well as food intake. Those have changed in many families drastically since the 1970s. Kids today are more likely to spend most of their time indoors in sedentary sort of activities as compared to kids a couple generations ago. They're more likely to be eating fast foods and heavily processed foods that tend to put weight on them, as opposed to the old-fashioned diet that we had years ago. So what to do? Obviously, we need to influence the activity patterns and diets of children. One of the best advice that experts give is that parents are really kind of key here. If parents will model the proper eating and activity habits and then encourage their children to follow that example, then they will be most successful in helping their kids with that. So it's kind of doubly beneficial if you think about it. It's good for the parent to do this for their own health, and also will encourage better habits to prevent obesity. So this is a big concern, by the way. Now, a lot of people used to say, when they get older, they'll burn it off and so forth. But the actual scientific evidence indicates that if children are obese in middle childhood, there is a high likelihood that they will continue to be so throughout the rest of their life. And so this is an important time to tackle those activity and eating habits. Now, when it comes to health in this time period, physical activity then is extremely important. And so spending significant time in active play benefits kids. When you look at the benefits, of course, the physical fitness that they get, the development of the motor skills, but it also helps them develop their social skills as they interact and play with other kids actively. It helps prevent problems like depression, and may even help prevent hyperactivity, helps kids concentrate better. This has tons of benefits. Now, on the other hand, it is true that when kids are engaged in active play, there are risks. And yeah, I know, I used to climb trees, fall out of the trees, and all kinds of things. There are the risks. So here's the thing. Today, many parents are afraid to allow their child to engage in active play because of the risks. What we really need to do, though, is we need to make it possible for them to participate in active play in the safest way possible, rather than denying them the benefits of active play. So that might mean if the child is going to ride a bicycle, that we equip them with a helmet, maybe other protective gear, and then make sure that they ride that bicycle in a safe environment rather than in the middle of a busy street. And that they also know the proper rules of riding a bicycle. So if they can learn to do it as safely as possible, they can get the benefits. And yes, maybe occasionally we will have an injury or so, but it's less likely to be severe. It's less likely to happen. So that's the thing we need to keep in mind. And by the way, not only do kids like not only do they need that active play for their health and their development, but they also have a strong urge to engage in that sort of play. And so if we completely thwart that, they're going to have some other difficulties as a result. So how do kids, traditionally, how have they gotten that active play? One was through neighborhood play. So they were able to go out and run around the neighborhood with the other kids that were roughly their age. Neighborhood play then inclusive, and you just show up, right? And also active, and it's also interactive because it involves them with other children. So it helps them to develop their social understanding as well as physical activity. However, neighborhood play does require some space and does require the ability to get out and move around the neighborhood. Again, today, many parents fear that if their child is out in the neighborhood, that harm will come to them, that a stranger will come along and abduct them, and so on. In most neighborhoods, those fears tend to be exaggerated. Yes, in maybe some significantly dangerous neighborhoods, the dangers might be real. But again, we can mitigate some of those fears by providing supervision for kids. So maybe, for example, you have family that lives in a small apartment, and neighborhood play is not possible because, well, there just isn't a neighborhood. You got your apartment and you got the street. In that case, what we might do is we might get together a few of the child's friends, have a little play date, and take them all down to the park where they can safely run around, and we can be, somewhere nearby, maybe not on top of them necessarily, but nearby, so that it can be safe and they can enjoy that activity. So often today, it's going to involve the parents and other caregivers involved to make that possible. Now, a second avenue traditionally that kids got that physical activity was exercise at school. So recess time, where they have an opportunity to go out in the playground or the gymnasium, as well as then PE classes. Now, here's the thing you should know, that in many places, the opportunities for exercise at school have been greatly reduced or even sometimes completely eliminated. Some schools in some places of the country have eliminated recess. Yeah, you heard it right. Can you believe it? Luckily, here in the Rio Grande Valley, we haven't seen that, I don't think, but there are some places that they've done this. Other places, they've also eliminated PE classes, or they've reduced the number of times that kids have PE class. Maybe they'll have them 1 year, but not for the next year, and so on. So you might say, well, why are schools in some places doing this? It's the focus on high stakes tests and getting high test scores. So their motivation is to use that time that they would normally have in a PE class or recess in order to drill things that'll be on those high stakes tests. Unfortunately, developmentally, that's counterproductive because kids need movement. They need that active time in order to focus and use their minds. So not a very good strategy. And again, here in the Rio Grande Valley, we've been pretty lucky not to see a lot of that, but know that other places of the country, this does occur. Now, the third avenue for physical activity amongst kids in middle childhood has been organized athletics. And so athletics teams that they can join and play on, these may benefit kids when they're properly administered. And so there are some limitations, though. In fact, sometimes if you're poor, if you're disabled or you're uncoordinated, you can't participate, okay? If you're poor, you may not be able to afford the uniform that you need to buy in order to participate. Or if you're disabled, well, there may be no position that is open to you that you can play due to your disability. Or if you're just an uncoordinated, unskilled kid athletically, yeah, maybe you could actually be on the team, but you don't really get any benefit because you never get to play. Now, a lot of that has to do with how the program is administered. So if we have programs in which there's minimal cost, or there is aid to lower income children where they can participate too, we overcome some of that. If we can also devise a way that the child with a disability can participate, okay, that's another thing that we can look at. And then we also should recognize that in these programs, the primary really goal needs to be that the child gets that physical activity and gets to develop their skills and abilities. So every kid needs to get to play a significant amount of the time. And of course, that all goes to, yes, if we only make the one goal that your team wins, then we sort of have short-circuited the goal of helping kids to get the active play that they need. So that said, programs that take care to look at these aspects can be very beneficial, even if you fall into one of those categories. And I might mention, I think we should all advocate that there are programs out there that do that. Okay. Now, let's shift to focusing on cognition and the development of thinking and other types of mental processing in middle childhood. And so we'll go to Piaget's cognitive theory first. Piaget says the child now enters the concrete operational period. And at this time, the biggest advance that is made in their thinking is that they now can begin to reason logically. So they can use logic. However, the logic is limited to what? Tangible things the child can touch and handle, and that the child has had direct experience with. So they can apply logic to these sorts of things. On the other hand, they cannot apply logic yet to abstract things like ethical questions and so forth, okay? But that's a big advance. So at this point then, the child also then can begin to engage in classification of things on the basis of logical principles. So they can begin to organize things into groups by certain rules of certain common characteristics. So they can learn the characteristics of mammals, and then they can decide if various animals should be considered a mammal or something else. Works pretty well until you come up with a weird one, but you get the idea. Now realize that they were not able to do that before this time. They also can engage in transitive inference. So they can figure out or infer the unspoken link between one fact and another and transfer those qualities from one to another. For example, they can begin to grasp the concept that if A is larger than B, well, let's say A is more than B, A is greater than B. That's right, that's the word. A is greater than B, and B is greater than C. Therefore, A must be then greater than C as well. Okay, and same thing in terms of sizes and various animals. If elephants are larger than dogs, dogs are larger than mice, then they can figure out on that basis, elephant must be larger than a mouse as well. Now, that all goes just fine until we actually introduce something that is contrary to their experience. For example, if we give them a hypothetical example that elephants are smaller than dogs, dogs are smaller than mice, and then they're asked to, what's the relationship between elephants and mice? Given that hypothetical backwards example, their answer should be, well, elephants therefore must be smaller than mice. But instead, what they will do is they will give you the answer based on their experience of seeing an elephant and seeing that it was larger than a mouse. So again, they can't reason abstractly, but where those things are consistent with their experience and logic then can be applied to it. Now, they also can engage in seriation. Now, they can organize things into series based on some criterion, whether it's organizing it by length or organizing it by number. So this is a skill that's critical for understanding the number sequence. So this enables them to more readily begin to grasp the concepts of mathematics, for example. Now, the progress in developing these logical capabilities is more gradual than Piaget predicted. In Piaget's view, the child just reached some level of maturation by virtue of their nervous system maturing. And at that point, it was kind of like nature would flip a switch and now all of a sudden they'd be able to do these things. It turns out that it seems to be much more of a gradual process than what he saw. And whereas Piaget would say, well, they can now learn math because they're capable of logic, what the actual experience of people who work with children shows is that, well, no, they're really kind of learning logic through engaging and learning about math rather than learning about math because now they can do logic. It seems to be that as they work with this, they're developing that ability. Now, the truth is, they probably would not be capable of that before they've reached this level of maturation. So Piaget's right there, but it seems that experience with the mathematical process is actually necessary for them to develop logic in that area. So Piaget was correct about a couple of other things that he noted about kids in middle childhood. He noticed that they were less egocentric in their thinking, so they were now able to grasp how other people thought and felt more readily than before. And they were also more flexible in their thinking. So when they directly observed something that differed from what they previously believed to be the case, they were now capable of adjusting their beliefs on the basis of their experience. Now, as we do several times in the course, we're going to sort of contrast the views of Vygotsky and the social cultural approach with those of Piaget. So Piaget's emphasis was on maturation and discovering new ways of thinking. On the other hand, Vagotsky emphasized the social cultural context of learning. And so looking from Vygotsky's vantage point, then the importance of instruction is key. So as we are mentored by more experienced individuals, whether they be more experienced peers or teachers, parents, those teachers and parents then become a bridge from where the child is now to where they could potentially be. And so in Vygotsky's view, this instructional process then was key in order to develop children's thinking. And they then needed models who helped mentor them. Now, there's a lot to also suggest that Some aspects of Vygotsky's view is also accurate. For example, we have the early kindergartner study. Let me tell you about that one. So researchers identified a group of children and enlisted them through getting permission from their parents that they could study. And this group of children was comprised of two groups. One group of children who were just a little too young to enter kindergarten that year, just a few days, anywhere from just missed the deadline to a few days. And then another group of children who were just barely old enough to start kindergarten, just barely made the deadline, again, at most by a few days. So essentially you had both groups about at most a week difference in their age, if you look at both groups together. Okay, so the school year started. Oh, I forgot to mention, they measured the intelligence scores of the children, okay, all of them. Then the kids who were old enough went off to kindergarten for the year. The kids that weren't old enough, of course, didn't go. At the end of the school year, they once again measured all of the children's intelligence scores, and they found that the kids who actually had attended kindergarten had shown an increase in those intelligence scores significantly more than kids that did not go to kinder. And so this indicated, yes, even though the kids were essentially the same age, they had different experiences in terms of what they were able to learn and different experiences in terms of advances in their thinking abilities. So this and many other studies indicate it's not just maturation and discovering these things on our own, but also the influence of instruction. And as we look at statistics, there is a significant correlation between quality teaching and the amount of learning that children do at this stage, the amount of advance in their thinking. Now, when it comes down to it, then as Vagotsky also predicts, culture influences just what is learned. And so let's have a little example here. Okay. Studies of school-age street children in Brazil. These kids, street vendors like you see here, and if you've been to Mexico, you've probably seen some kids that do the same thing. And what they found out is many of these kids, even though they never went to school, they were really advanced in their math capabilities for their age. You know, if something was so much, they could calculate how much is a dozen, how much is 18 of those items. What about if we want a discount? Okay, well, with the discount, how much is it? They were also able to even compensate in fluctuations of the value of the currency in Brazil. And so when the value of the currency went up, they were able to calculate how they needed to adjust the price of their product so that they could still make a profit. Pretty amazing for children that age. And they found, in fact, these children were far more advanced in many mathematical skills than their peers that were the same age and were attending school every day. So why is it these kids were so advanced, even though they didn't go to school? Well, for one thing, their situation demanded that they develop these abilities. It was necessary. So they had a motivation for it. And they learned from others. Who did they learn for primarily? The kids who were out there doing this who were more experienced than they were. And some of them would sort of mentor them into how to calculate all this stuff. And they would learn it. And they practiced it daily. With daily practice, they got good at it. And so they developed a good knowledge base when it came to using math in terms of selling things on the street. Now, they were better than kids that went to school every day. There were also some of these kids that went to school kind of part-time as well as selling things on the street, or I should say they went to school full-time and they sold things on the street when they were not in school. Who was best at the math skills? It was these kids who had both the book learning, if you will, who learned math at school, and also who practiced it and learned it on the street, had the street smarts. So that's a good combination of book learning and street smarts. But at any rate, notice that in fact, their command of math went beyond what Piaget would have predicted. Why? Because of the influence of mentors, demands of the situation. So this suggests that kids can advance beyond what we might predict. Now let's shift to the topic of information processing theory. So this is a somewhat more modern approach to cognition, where we compare human cognition to how computers work with information. So in each case, you have the processes of input processing, storage, and output. So with computers, you might have input in the form of files that are downloaded. You might have information that is being typed in. What about humans? Well, information comes in primarily through our sensory systems, our vision, hearing, so forth. Then in processing, so once the information is in there, well, actually, storage has to come first. It has to be stored temporarily before it can be processed. So let's talk about storage. So in computers, yeah, information is stored electromagnetically, as I understand. What about the human cognition system? In this case, information is stored in the form of neural networks that then are formed to store that information. Once we have information in the system and it's stored long enough to work with it, then we can process that information. So at a computer, you might cut and paste, use spell check, so forth to process that information. Various cognitive processes performed by association of our areas of our brain in our human processing system take care of that. And then you've got output. So with your computer, the output might be what comes up on the screen, or maybe something that you print up on a printer, or that you send out, so on. And with us humans, the output may be some actions that we take. Okay, so all of this, there are some close parallels. Now, when you have a computer buff who's out to buy a new computer and they want to get the best one they can, what are the two main things that they're going to be interested in? Well, usually it's going to be, well, how much storage capacity does it have? You know, how many gigabytes or terabytes now, right? When we look at the human information processing system, we also can look at the storage capacity of various parts of that system. The other thing the computer buff will look for is, well, how fast does it process information? You know, what kind of processor and how fast is that? And indeed, we also can measure that in terms of human information processing as well. So you see many parallels here. So what we will find is that there are many factors that improve each of these processes in humans. And much of this has to do with brain maturation. So the maturation of the corpus callosum, this band of neurons that connects the left and right hemispheres of the brain, enables information to move back and forth between the right and left sides of the brain more effectively. And so that enables improved two-handed coordination as kids go through this time period. There's also maturation going on in the prefrontal cortex of the brain, that forward outward layer. And there is also improving communication between brain areas. and neurons that connect one area of the brain with others are maturing, branching out. This maturation enables kids to master more complex tasks, things like reading and writing, using logic, and also making social decisions, how to interact effectively with others. That can be pretty complex, right? And also enables kids now to begin analyzing the consequence of their behavior more readily than when they were younger. When it comes to speed of processing, then this increases in middle childhood, in part due to maturation, development of more efficient neural pathways, these neurons that interact together in order to perform various tasks. Now, those neural pathways improve as dendrites branch out and make new connections, and as new synapses are formed, new connecting points between various neurons. The pruning away also of connections that are not useful helps these neural pathways to become more efficient. One of the things also that occurs then is that as they begin to automatize tasks, to begin to do them automatically, there is less thinking required to perform tasks. So this process of automatization, try to say that a few times, helps them to actually process more information in less time, speeds up processing. You say, how so? Okay, well, what they've found when a child is first learning a new task, let's say they're learning to tie their shoelaces. What they find is this requires a tremendous amount of frontal cortex activity. A whole lot of brain cells have to be active at first to do this task, being unfamiliar and new. Now, as they repeat the task over and over again, those neural pathways become more efficient, so it requires fewer neurons to be involved. And this then begins to free up those neurons to engage in processing other tasks. So as the task becomes more automatized, then the ability to do other things is improved, as well as the processing is more rapid. Now, all of this efficiency that they're developing, especially when it comes to academic tasks at school, some of that efficiency may be lost during summer vacation when they're away from school and not exercising those neural pathways that they were at school. Then these neural pathways may weaken somewhat and need to be refreshed when they get back to school in the fall. Now, when it comes to information processing, another thing that enables them to do this more effectively is their ability to engage in selective attention improves. So selective attention is the ability to attend to relevant stimuli, that which is important, while filtering out distractions. And so their ability to pay attention to what's important improves. And therefore, they're able to also more readily select what should be remembered as well. And so, case in point, you know, if you've got a 4-year-old and you ask them to sit down and listen to something, before you know it, they're thinking of something else and so on. As they get into middle childhood, they're able to focus their attention for longer, and that means they're going to pick up the important information more likely, more readily. And because they can also select more readily what should be remembered, they're more likely to remember the important parts of what they're learning. Yeah, this is kind of interesting. If you've ever been around, again, younger children before middle childhood, they'll remember all kinds of weird details about situations, you know, that are really unimportant, but maybe totally have no awareness of the important details of that situation. once they get older into middle childhood, they're more likely to focus in on the most important aspects of the situation they're encountering. So that all improves their information processing. But let's look then specifically at memory in terms of information processing. So there are basically three types of memory storage in terms of the length of time, the duration of storage. And we have sensory memory or sensory register. We have working or short-term memory. And then we also have long-term memory. So what we're going to see is that to some extent, each of these improves during middle childhood, enabling them to remember more readily. So sensory memory, let's look at that first. Sensory memory simply is registering incoming stimuli. So for example, whatever is in your visual field, that first comes into sensory memory. So the entire scene that you're looking at, all of that comes in there into sensory memory. Now here's the limitation though, that visual sensory memory only lasts a split second. If you close your eyes, that visual image disappears in roughly half a second, and whatever you haven't paid specific attention to will be lost and forgotten. Only those things that you actually attended to directly will be available for usage after that. So tremendous amount of information, short time. In terms of auditory information, sounds like words or phrases and so forth, here we have maybe sensory memory for 3 or 4 seconds before that totally fades away. And so what that means is, yeah, if you don't listen to what somebody said and pay attention to it within 3 or 4 seconds, it's going to be lost, and then you'll have to say, what did you say? I'm sorry, I don't pay attention. All right, now, here's where the advances come in terms of sensory memory. Kids get better at selecting which stimuli coming in that sensory memory should be selected for processing, that they should hold on to so that they can engage in this process of perception and interpreting that information. Okay, so being able to pick out what's important in the scene helps them. All right. Once information has come in through sensory memory, then it can be encoded into working or short-term memory. So what are the characteristics of short-term working memory? Well, short-term working memory is able to hold a limited number of items in terms of numbers or letters. Research done by George Miller many years ago indicated that people can remember 7 plus or minus 2 numbers or letters. In other words, somewhere between 5 and 9. So it appeared when it comes to that kind of information, we've got somewhere between 5 to 9 items, working memory slots as adults. Now, children have fewer than adults. We'll get to that. But okay, working memory then is the concept, not only are we holding that information in memory by repeating it and rehearsing it over and over again, but we also then can work with and process that information. So an example might be imagining your living room and the furniture in that room, and then imagining how you can rearrange that furniture to make it more effective. That would be using short-term memory. You continually keeping that in your awareness and then processing it by mentally moving it around. So that is what we call visual spatial sketchpad, okay? Now we also can have various sounds in working memory, and this is what we call phonological loop. An example is if you look at a piece of paper that has a phone number, the piece of paper is fixed and you can't move it anywhere. So you repeat that phone number in your head over and over again as you look for your phone so you can dial the number. And then as long as you keep repeating it and looping it mentally, it's there for your awareness. Now, what we have is working in short-term memory improves steadily between age 4 and 15. Part of that is due to, it seems, the number of memory slots are increasing. And so the younger child might only have 4 or 5 of those memory slots. And as they get older, they're moving up to 6 or 7, so on. Okay, so that's one thing. Why? Why are they developing greater capacity hold on to information? Because of the development of myelination, development of the myelin sheath over the axon of neurons that may be involved with memory process, and also the formation of new dendrites that produce new connections in the prefrontal cortex. Okay, so working in short-term memory improves, and then long-term memory, finally. Long-term memory is really anything that we can remember that is no longer in sensory or short-term memory, if you'll put it that way. So they've actually found that in terms of short-term memory, things don't stay there more than about 20 seconds. That's right, 20 seconds. If we don't keep looping them and rehearsing them, keep them directly in mind. So you could say really things that are beyond 20 seconds are already moving to long-term memory. So long-term memory then can hold information anywhere from minutes to years to a lifetime. And the capacity here, virtually limitless. Now, I know they've tried to calculate how many trillion bits of information we could store in long-term memory, but the reality is it seems like we can always add more. So effectively, there seem to be no actual limits to it. What they have found is that language development contributes to improving long-term memory. And so as the child develops verbal capacity, that they can verbalize events and so on, they tend to remember them better. Same thing for words and concepts. If they can, again, verbalize them due to advanced language skills, then they can remember those things better. So as they're also accumulating knowledge in long-term memory, they now have an increasing knowledge base. And you might have heard when you learn something, you're really associating it with something you already knew. Now they've got more, a base of more things they already know that they can now associate new stuff with. So that helps them to accelerate their learning. Okay, so those storage processes do improve in middle childhood, but the real story about memory improvement at this point really has more to do with improving the retrieval processes. Okay, yes, memory storage capacity is expanding over childhood. These memory systems can contain more information. They're having an increased knowledge base that enables them to store things more deeply, but really it's the improving retrieval skills that then enable them to more readily retrieve stored material and bring it back into working memory. So as their prefrontal cortex matures then, children are then better able to use retrieval strategies that help them remember. Okay, so retrieval strategies. That brings us then to the topic of metacognition. Okay, so metacognition can be defined as thinking about one's thoughts. That's what the textbook says. Now, to me, that wasn't really helpful. If you want to put it a different way, metacognition is really understanding how thinking works. Okay, so if you can understand how thinking works, you can come up with strategies to improve your thinking. And so we can also look at meta memory. Meta memory, understanding how memory works. So as kids get into middle childhood, they begin learning how memory actually works, and they then can make up a strategy to engage in cognitive tasks. They can then monitor their progress and adjust the strategy if it's not working. So when it comes to memory and meta memory, some of those strategies then involve mnemonics, memory tricks. So things like what? Grouping things into categories for better recall, the strategy of rehearsing information and repetition, the strategy of maybe using rhymes to remember things, or how about the strategy for memory of clumping things together, something they call chunking, for example, to remember the colors of the rainbow in the correct order. One would learn the name Roy G. Biv, and it turns out you can use that to remember those colors: Roy, R-O-Y, red, orange, yellow, and so on. So notice strategies really rocket their ability to learn now. And here's an example of where this showed up in some experimentation. So they had kids of various ages to try to remember a list of things. And then they tested them on their ability to remember all of the things on the list. They noted that younger children would just simply try to remember each of the items separately. However, older children, 9-year-olds and up, did better than kids younger than 9. Part of the reason, they mentally organize those lists into groups. And so, you know, the 9-year-old or 10-year-old might think about it and say, the list, okay, well, there's fruits on the list and there's animals. And so categorizing these mentally into lists help them to recall the items. So that's the use of a mnemonic memory strategy, all part of meta memory and all part of metacognition. Now, also, part of this is knowing what has been learned as opposed to what needs to be learned. Again, kids at this age now begin to grasp that, and so they can identify those spelling words that they don't know how to spell, and they can focus their energy on those rather than simply reviewing all of them, and they can advance more rapidly then, as an example. At this point also, they can begin to analyze errors in their thinking, which they couldn't do before. So a younger child who makes a mistake on a math problem, they just go, I don't know, I got it wrong, you know. They have to wait for the teacher to show them what they did wrong. Children in this age group, many times, they can go back over the steps in the problem and they can identify where they made a mistake once they know that they did it wrong. So that enables them to move forward as well. They don't have to wait for somebody to tell them where their error was and correct it later. So again, if we look at all this, you know, you can look at this and you can argue, is this a matter of discovery, that they discover how to use these strategies on their own? I think you say, well, probably sometimes. Or is it a matter of scaffolding and someone organizes the learning and gives them the tools maybe that they use? Well, maybe it's some of that too. So maybe again, we do well to pay some attention to both of those theorists. Okay, we're going to stop there in order to not get too terribly long on this one. And the next video will pick up with language advancement in middle childhood and the specifics of teaching and learning. We'll look at aptitude and achievement, particularly intellectual aptitude and intellectual IQ testing. So we'll do that next time. Okay, so have a great day, and we'll stop there.